Hey guys, what's happening? We're going to continue looking at lines and angles formed by a transversal, but today we're dealing with parallel lines. So line M and N are parallel to each other, and when that happens, something magical happens. The corresponding angles are congruent. We saw that in class whenever we made our constructions. So when M and N are parallel, I know angle 1 is congruent to angle 5 because corresponding angles are congruent. Alrighty, so we're going to see what we can figure out all from that postulate and a little bit of other knowledge that we have. So let's go to this one. I want to prove something about angle 1 and angle 7. And what I know my line M is parallel to line N, and I know that because it's given to me in the figure by those marks. So that's my statement, that's my reason. And I want to try to prove something about angle 1 and angle 7. Well, one thing that I know already is that angle 1 is congruent to angle 5 because I know that those guys are corresponding angles. So my reason would be the corresponding angle postulate. Cool. So now that I know something about 1 and 5 being equal to each other, can I make it to angle 7? Can I relate that angle 5 to angle 7? Yes, I can. Because angle 5 and angle 7 are what kind of angles? And you're probably saying vertical angles, I hope. So angle 5 is congruent to angle 7 thanks to that vertical angle theorem. Nice. Now that I've done all this work, is there some way I can go from angle 1 to angle 7? Let's see. Angle 1 is congruent to angle 5, and angle 5 is congruent to angle 7. Well, hopefully you remember some of our properties that if we have a statement like this, we can kind of skip the middleman and just jump straight from angle 1 being congruent to all the way to angle 7. I hope you remember what that's called. When I skip the middleman like that, that's called the transitive property. And because I'm dealing with things that are congruent, it's the transitive property of congruence. So I've proved that angle 1 is equal to angle 7 using postulates, theorems, and properties. So what does that mean to us? Well, let's take a step back and look at what kind of angles they are. Angle 1 and 7 are a pair of alternate exterior angles. So we've just proven that alternate exterior angles are congruent if a transversal intersects parallel lines. Cool beans. Let's see what else we got. All right, up next, I'm trying to relate angle 3 and angle 5. So, again, we're given that M and N are parallel to each other. And again, it's because of these symbols. So I know angle M is parallel to angle N, and I know that I can relate angle 3 to angle 7 because those are what type of angles? Corresponding angles. Cool. And then now, can you relate angle 7 to angle 5? I hope so. I hope you realize that just like the last, that is a pair of vertical angles. So angle 7 is congruent to angle 5 thanks to that vertical angle theorem. So just like the previous one, I see that I go from angle 3 to angle 7, then angle 7 to angle 5. And I remember that that means I can say angle 3 is congruent to angle 5 by the transitive property. Sweet. So what kind of angles were 3 and 5? Angle 3, angle 5. Those were alternate interiors. So if I have a set of parallel lines, I know that those alternate interior angles are going to be congruent. And we could call that the alternate interior angle theorem. Already on this one, again, we're given that M and N are parallel. So M is parallel to N because I said so. Well, because the figure said so. And now, what do we know? Again, like all the others, we know that 4 and 8 are congruent because of the corresponding angles postulate. And, kind of cool here. What do you know about 5 and 8? We're trying to relate 4 and 5 together. We know 4 and 8 are related, they're congruent. Now, what do you know about 8 and 5? They're a linear pair. A pair of angles sitting on a line must be a linear pair. So we know that that means 5 and 8 are supplementary. Angle 5 and angle 8 are supplementary because they form a linear pair, so we call it the linear pair theorem. So if they're supplementary, then I know that angle 5 plus angle 8 equals 180 degrees because that's the definition of supplementary. All right, now what can I say? I know that 4 is congruent to 8, so maybe I could substitute and replace the 8 down here with this 4 because they're the same. So I can do that. I can say angle 5 plus angle 4 equals 180 thanks to substitution. I guess there should be little m's here for the measure of the angles. Oh, and then I can say, hey, if those guys add up to 180, then angle 5 and angle 4 must be supplementary. Because if they add up to 180, that means they're supplementary thanks to the definition of supplementary. We know what supplementary means. Cool. So we just proved that the relationship between angle 4 here and angle 5 is a little bit different than the previous two. Those guys are supplementary. So those are same side interiors. And we just proved that when you have parallel lines, those same side interiors are supplementary. Nice. Alrighty, another situation. This time we're relating angle 2 and angle 7, those same side exteriors. And again, we're given the same stuff. We know we are dealing with a set of parallel lines. And we know that we can relate angle 2 to angle 6 because they're corresponding. Okay, and we also know that angle 6 and angle 7 form a linear pair. That means they add up, or it means they're supplementary. Because they are a linear pair. So I'll call that the linear pair theorem. Oops. It'd help if I spelled theorem right. Let's just put an M over that. Alrighty, what else is going on here? So if they're supplementary, I know that means that they add up to 180 degrees. So the measure of angle 6 plus the measure of angle 7 equals 180. And I know that because the previous step said they're supplementary. And I know that supplementary means they add up to 180. So let's see what we have here. I know that 6 and 7 add up to 180. And I know that 2 and 6 are the same. So I can take that 2 and plug it in for 6. So I can say the measure of angle 2 plus the measure of angle 7 equals 180. That was the substitution property. And lastly, I can say, hey, if they add up to 180, that means they're supplementary. And how did I go from one step to the next? Well, that's because I know the definition of supplementary. All right, so what I've just done is I've proved that angle 2 and angle 7, which are same side exteriors, I proved that they're going to be supplementary, just like the same side interiors. Cool, so let's kind of wrap everything. All right, what did we learn here? Today we already knew before going into this that corresponding angles, whenever we have parallel lines, corresponding angles are going to be congruent. But today we've learned that alternate exteriors are also going to be congruent, alternate interiors are also going to be congruent, and it's those same side interiors and same side exteriors that are going to be supplementary. So cool, I hope you learned something, and I'll see you in class.